Hello everyone, in this video I'm going to discuss the situation for normal distribution. If x is binomially distributed with n 200 and the probability of success is 0.7, use the normal approximation to find the situation. So first what we have to do is, the original is a discrete situation. So number one, we have to convert the title where we have x is normally distributed with mu, which is the mean, and the standard deviation squared, which is the variance. In order to obtain the mu, or we can say the mean, where we have mu is equals to np. So mu will be equals to 200 multiplied with 0.7, where we will have 140. Next is to find the variance or the standard deviation square, where we have npq. So meaning that the 140 multiplied with the 0.3, where we have the standard deviation squared, which is equals to square root of 42 squared. Kindly rewrite the title where we have n is normally distributed with 140 as a mu or mean, and we have the square root of 42 squared. So by referring to the map, as you all know, binomial is a discrete, and then for the normal, it is continuous situation. Next, do remember to have the continuity correction. So kindly refers to A, where we have probabilities that x is greater or equals to 130. So kindly refers to the number line. Let's say here we have 130. So then circle towards the right. Continuity corrections. So notice that we have a then circle. So what we have to do is to modify the situation, or we say the continuity correction, or the continuity correction, which is empty circle on the left hand side. So here we will have probabilities that x is greater than 129.5, which is 130 minus 0.5. So that is the first step, continuity correction. Continue. Standardize the situation where we have probabilities that x minus the mu, where we have negative 140 over, we have square root of 42 greater than 129.5 minus 140 over the square root of 42. So by referring to the calculator, so here we have z after we standardize, so greater than negative 1.62. So step number one is the continuity correction. Step number two, standardize the situation. Step number three refers to the diagram. So where we have the location, negative 1.62. Let's say here we have negative 1.62, which is the z. Then refers to the situation, z is greater than. So meaning that here will be our region. Step number three, formula. So by referring to the situation, what we have to do is to flip the situation. And we have z equals to 1.62. So kindly provide the formula. So where we have 1 minus probabilities that z greater than 1.62. So by referring to the table, so here we have the table for the standard normal distribution. So given the z is 1.62, so refer point 1.6, and then we have 0.02. So the situation will be 0.0526 for z, which is equals to 1.62. So here we have 1 minus 0.0562. So by referring to the calculator, so where we have the probabilities that x greater or equals to 130, the probability will be 0.9474. Kindly refers to B, where we have the situation, probabilities that x is greater or equals to 136 less than 148. So step number one is to have the continuity correction, because at the starting point we are in the binomial distribution and now we are normal approximation. So by referring to the number line, so here we have 136 and 148. Then circle, empty circle. So remember the continuity correction. So in here we have the then circle, so we have to create the empty circle. Next, for the second part, we have the empty circle. So here we have to create the then circle. When we have the then circle, we need an empty circle. And when we are having the empty circle, we need a then circle. So here is the situation for continuity. So remember, for this part, we have to minus 0.5 Same goes to this part. We have to minus 0.5. So the probability will be x, which is less than 135.5 because minus 0.5. Next, we have then circle 147.5. Again, also minus 0.5. So that is the first step, continuity correction. Second step is to standardize the situation where we have the probability 135.5 minus 140 over the square root of 42. We have z. 147.5 minus 140 over the square root of 42. So kindly simplify the situation. We have probabilities that z is greater than negative 0.69 less than equals to 1.16. So that is the product after we standardize the situation. Next is to refer to the diagram. Next, we have to plot the location where we have the z negative 0.69. We have the z 1.16. Shaded the region. Next is to create the formula. So what we have to do is to minus this part and also this part. So the formula will be 1 minus probabilities that we have to focus this part, which is z is greater than 1.16. So it doesn't matter whether it is greater or greater than equals, because for this case, now we're in continuous. So sign is not important. Next, we have to minus this part. So where we have probabilities that z, which is greater than 0.69. So kindly refers to the table. So now where we have the standard normal distribution, so number one, we are interested in 1.16. So 1.1 and then 0.06. So we have the answer 0.1230. Next, we are interested in 0.69. So the answer is 0.2451. So in here where we have 1 minus the probability that z greater than 1.16, where we have 0.1230 minus the probability for z greater than 0.69, where we have 0.2451. So kindly simplify the situation and we will have the probability that x, which is greater equals to 136 less than 148, the probability will be 0.6319. Next, we have C, where we have the probabilities that x is less than 142. So remember, the starting point is the binomial. So now we are using the normal distribution. So remember, continuity correction. Kindly refers to the number line where we have 142. We have the empty circle towards the left. Remember, if we have empty circle, we must have the then circle where we have in this part. So means that we have to minus 0.5. So the probabilities that x is less than equals to minus 0.5, where we have 141.5. So that is the process for continuity correction. Second step, standardize the situation. So probabilities that z is less than equals to 141.5 minus 140 over square root of 42. So the probability is that z less than equals to, after we simplify the situation, so we will have 0.23. Continue, refers to the diagram, where we have the z 0.23. So refer, z is less than equals to 0.23. So here will be the shaded region. Next, what we have to do is to create the formula, meaning that eliminate this part. So we have 1 minus probabilities that z greater 0.23. So for this case, sign is not important because we are in the normal distribution. Kindly refers to the table. So here we have the standard normal distribution, 0.23. So our answer will be 0.4090. So here we have 1 minus 0.4090. So simplify the situation and we have probabilities that x is less than 142. The probability will be 0.5910. D, where we have the probabilities that x greater than 152. So number 1, continuity correction. Because our starting point is binomial distribution, which is the discrete, then we have to normal the approximation, so we are in continuous. So continuity correction is needed. So where we have 152, empty circle towards the right. So remember, when we have empty, means that we need a dense, which is inside the interval. So in this part, we need to add on the 0.5, where we have probabilities that x is greater equals to 152 plus with 0.5. So 152.5. First step, continuity correction. Second step, standardize the situation. Greater equals to 152.5 minus 140 over the square root of 42. So kindly simplify the situation where we have z greater equals to 1.93. By refers to the diagram, where we have the z which is equals to 1.93. So z is greater equals to 1.93. So here will be the region. So the formula will be z is greater than 1.93. Remember, sign is not important, meaning that you may write z which is greater than 1.93 is the same for z which is greater equals to 1.93. Kindly refers to the table. So in here we have tables of standard normal distribution. We are interested in 1.93, 1.9 and then 0.03. So the answer is 0.0268. So where we have the probability x greater than 152, the probability will be 0.0268.